It's my joy to open up this session on the introduction to value creation with microgrids and to get to introduce this distinguished panel to you. First, really quickly, my name is Kimberly Holcomb. I'm the Director of Marketing at Spirae. So we're hosting this session today, and we invited some of our partners and other leaders in the industry to be with us here to really get into the depths of the values that are possible through microgrids. To set the stage on the workshop overview, distributed energy is the means to an end, not necessarily the end itself. Today we're going to do a deep dive into some of the many values available through the deployment of microgrids for any end customer application. The range of what's possible through microgrids is really only expanding as this space continues to expand and energy consumer needs grow and develop. Microgrids are vastly powerful, and they are enablers of the values that end customers are looking for connecting DERs to those facility operational objectives, and then also to service business models as well. Before we dive into too much of the discussion of the values of microgrids, let's do a little level setting on just the term microgrid itself. I'm sure all of you guys can agree that that term has lots of different meanings depending on who you're talking with and what space you're talking in. It's only continuing to evolve also as this space continues to expand and the number of microgrids deployed increases. This term's fluidity is partly due to the fact that it lives in the context of multiple definitions. You'll see some of those key terms up there as well. When some people say microgrid, they may think VPP, virtual power plant. Some may think distributed energy system. They may talk about, I think I was just talking with someone in the back about microgrid energy management system, or just the term energy management system. So, et cetera, that list goes on. I'm sure in your space, in your company, in your daily conversations, there's multiple terms that come up in the context of microgrid. It's commonly thought as well that there's a definition of that they are able to be islanded as well as grid-connected mode. But what if you're operating a system that is fully islanded? Is it still a microgrid? However, today, for the purpose of this discussion, talked with the panelists, we all kind of centered around the definition that you see here at the top, with microgrid being a group of interconnected loads with distributed energy resources that act as a single controllable entity. And they operate in multiple modes to capture these value streams that we're going to discuss today. Those modes could be island systems, it could be grid connected, operating just from an economic standpoint, or grid connected with the key value being that resiliency piece. So that is what microgrids are made for, the ability to mix and match DERs, objectives, to meet specific needs at specific locations. More like a Swiss Army knife for multiple applications rather than a single silver bullet for one specific area. I just want to give a quick orientation to the topics that we'll cover in the flow of that before I hand it over to them. G&W Electric is here with us today, and they have an industrial microgrid that's supporting both critical and non-critical loads. We'll look at how to manage that complex sequence of operations necessary for that microgrid. Next, Intelligent Generation is here to talk about grid services and the additional value that you can unlock through the assets that you have within your system. So they're going to have a frequency regulation market participation demonstration of a system that they have in operation as well. Then Rolls Royce is going to talk about the need that they fit for that emergency backup power, especially for critical facilities. And then how to take that need and also add on additional value as their customers are wanting to move towards net zero carbon emissions. After all those, we'll have focused on individual microgrid projects. Next, Intel is going to connect it all up and talk about how to take these type of solutions to the market at scale. So in order to do that, you need a really solid infrastructure in place, and that's where Intel really shines in that space. So here to talk about that secure modular infrastructure software for edge applications, and then we'll look at that in demonstration as well. Lastly, Spirae will bundle it all, talk about how to stack those benefits in a way through configurability and scalable software to enable those scalable business models. So, as you can see, full discussion today, lots of content to go through. So without further ado, let's meet the panelists that are going to be leading the discussions. So we have Kate Cummings here from G&W Electric, and they provide both electrical components and engineering services. Like I mentioned, gave you a sneak peek, they're operating a microgrid at their headquarters that combines multiple values that Kate will share with you shortly, and they deploy microgrids also in front of the meter and behind the meter application. So as such, she brings a really unique perspective of being on both sides of that end customer value, being a customer and then also serving the needs of customers. Also joining us from Chicago, we have Dave Braun, the Vice President of Sales and Marketing at Intelligent Generation. Intelligent Generation is a virtual power plant provider that optimizes the economics of energy storage and that asset at commercial and industrial facilities. So today, the demonstration is going to focus primarily on the PJM region, but they also have other grid services that they enable as well. Raman Ramireddy from Rolls Royce is here to discuss the space that they fit in with both conventional generation and then also helping companies on their path to net zero. He's been with Rolls Royce for quite a few years now, both working in the Germany team and the US team, and we're excited to have him here with us today. Sam Harrell is the director of Intel's Center of Excellence, or I should say one of Intel's Centers of Excellence. These centers work with partners on solutions to address the needs in various industries, today focused on energy. They focus on outcome-driven disruption across the value chain, so they really help their partners accelerate that energy transition and sustainability objectives. Sunil is our CEO at Spirae. He's been in this industry for about coming on 20 years or so now with Spirae, and works on with the Spirae team on developing software that is innovative, scalable, and really helps take all these types of solutions to the market. Enough from me. I know you're excited to hear about this prestigious panel that we have here today. Kate, I'll invite her up here to tell you a little bit more about her role in the space that G&W plays in the microgrid and energy transition. Kate.
So just a little bit about me. I've been with G&W for about 16 years now. I started off in their production engineering, designing controls for the medium voltage switchgear. Moved over to product management for the controls, mostly hardware, a little bit of software, and then manager of power grid automation. So this is what our campus looks like today. We have our Viper reclosers that are providing an auto transfer between two sources, two completely separate substations from ComEd. Our 305 building does mostly assembly work, so we consider that not critical, and that houses our solar farm. Really, the solar farm sits on the house, but another story. Our energy storage is closer to our 245 building, which is considered the critical manufacturing, is that it's a molding facility. If it loses power for 5 cycles, it's down for a minimum of an hour while we clean up and have to clean out the ring lines, the presses, and all that kind of good stuff. So when you're running 24/7, even being down for an hour can put you behind. At 245, we have the flywheel that we use for ride-through so that there's not even so much as a flicker when we lose power. And then the genset, which is a diesel genset. It's a 2 megawatt. I'll show you in a little bit. So, needless to say, a project like this is not inexpensive. So we had to figure out how are we going to get our boss's money back. So it took a little bit of thinking of how are we going to use this besides premium power. First and foremost, we needed premium power for a molding facility, as we were seeing a lot of outages, and a lot, even like I mentioned, 5 cycles, a sag, we're down. So to us, that was a lot. So looking at the financial aspect of it, we looked at frequency regulation, or FR, which is through PJM, Pennsylvania, Jersey, and Maryland, which is our regional transmission operator, RTO. And you might ask, okay, well, you're in the Midwest, how did you end up in PJM? Well, ComEd is our distribution utility. ComEd's part of Exelon, so therefore, that's how we ended up within that. So 5CP is 5 coincidental peak days, and that is both through PJM and ComEd. They can be at the same day, we're all 5 days, or they can be completely separate 5 days. And what those are is they help develop, I believe it's called the demand response that's on our bill. So if we bring that down, we bring our bills down. So that was another aspect of how we can work towards recouping some of our money, some of our ROI, return on investment. There's also demand response from ComEd specifically for high load days. And then we looked at different tax incentives between state and federal. And then recently we received our rebate from ComEd, which is related to smart inverters and distribution generation. And in fact, that rebate happened exactly a week ago to the minute, and we got $2.6 million for that aspect. So that helped a great deal. So looking at the components within our microgrid, to start off with is our Viper ST reclosers and our 651 R2 controls. We installed those in 2014 when we were originally just in the 305 building and had some power issues. That gave us a higher reliability as we were looking at 2 different substations providing the power. Next is the flywheel. It is a pillar flywheel, and we do have Siemens bypass switchgear we use with this. I don't have that in the picture, but it's right next to it. It looks like it's just one complete product. So our solar farm, we're using LG bifacial panels, and no, LG does not make them anymore. They actually stopped making them about a year after we installed our solar farm. We also have some Tygo rapid shutdown devices. We have some that can handle 2 panels at once and others that are single panels. Those were required by our local village, as if any of the emergency services has to get to the roof, we basically need an easy button to hit and shut down generation so it's safe for them to be up there. We had about 2 or 3 years prior to thinking about doing this microgrid, we redid the roof. So the roof had a 25-year warranty. The owner said, you're not losing my 25-year warranty, so you need to figure out how you're going to mount those panels up there. So we worked at a company named Opson that's out of Montreal, and they use weighted racking. And they look like cinder blocks, but they're very specifically made. In the case, we used 31-pound blocks, and that's, it was rated for 140-mile-an-hour winds is how they determined what blocks to use. We have SMA string inverters, so there's almost 6,000 panels and 32 inverters up there. So for the battery, this is a little different than you're going to see for a lot of microgrids. We went with the flow battery, specifically a vanadium redox flow battery. The vanadium electrolyte came from US Vanadium that's in Arkansas. The battery itself is a 2 megawatt 4 hour, but we can run it over for 3 megawatt 2 hours if we have that need. We're also using SMA inverters on this, and then the ABB transformers to bring it back up to the medium voltage level. It's built with 4 500 kW blocks, making 1 megawatt batteries. So if you look at it, it kind of looks like they're a mirror image, and that was on purpose so that we had 2 separate batteries we can use should we need to take one down for maintenance, or if we need to do some kind of charge-discharge action. And next, with our medium voltage loop, of course we used our own switchgear. In this case, we used the Trident SR with SafeView. The reason we use the SR is it's magnetically operated, so that means it opens or closes in 2 to 3 cycles. So for the flizzer that we have in the medium voltage loop, or fault location, isolation, service restoration, we can reconfigure in cycles as opposed to seconds to keep everything going. We also have lots of PQ meters all over the place to figure out what voltages, what currents, what frequency, to look at power quality as well as health, as well as to have information that we need to be able to feed back to our tax people to show we are doing what we're saying we're doing. And the last piece of hardware is our ground bank transformer. The reason we need a ground bank transformer is when we isolate from ComEd, we no longer have a solidly grounded system. So we needed something to have that ground in there. And working with Quanta, we developed what the size of the ground bank transformer we needed. So enough of the hardware, let's look at the software. One piece of the software we're using is intelligent generation, and they're managing our frequency regulation through PJM, through the Wave software to us and back. So right now we're at about 22 hours a day, and then the other 2 is what we use to get back to our state of charge. Right now we're actually looking at possibly raising it to the full potential of the battery. We had to do some testing to figure out how much solar we can generate, how much of the PJM can we work with before we look at possibly overloading, feeding back. And it looks like we're going to be in good shape to fully run the solar at its full 2 megawatt capability, the full PJM, so 1 megawatt from each of those 2 batteries that I mentioned, and keep it going. And this will help our ROI. Next is the brains of the outfit. It's our Spirae Wave. We're using this as a microgrid control, and this is housed in the 305 building. And in this case, we have a whole separate room dedicated to it with multiple screens, so we can bring anybody in, customer, employee, whomever wants to see it. Lastly is our Smart View software. This is through Surveillant, which is actually our brother company. One brother owns the company I work for, and the other brother owns Surveillant. And what this is we call it our one pane of glass. So when we bring somebody in, they can take a look at and see the whole system, the health of the switchgear, the health of the medium voltage loop, the health of each component, and see what's going on. It gives us a way to show things without being afraid of actually committing operations that we didn't really want to do. There are ways to get under the hood, but there's only going to be certain engineers that have keys to that kingdom. So lastly, just kind of want to put a little tiny commercial out there for G&W's Power Grid Automation Solutions. We develop systems, we design them as a system, we test them as a system, and we deliver them as a system. Thank you.
That's amazing. It's so cool to see a system in operation like that already executing those values. Now to see the resilience piece of it in action. So she mentioned that a little bit of some of the critical facilities that they have there. I'm going to hand it over to Jackie Lynn. She's a systems engineer at Spirae, who's been at Spirae coming up on about 8 years now. And she's going to demonstrate the system that you just saw, all those components operating as a system in action in a resilient situation. So Jackie, take it away.
Thank you, Kimberly. I'm truly honored to have this opportunity to showcase how our product WAVE can significantly contribute to the resilience of microgrids. As you may be aware, WAVE have a wide range of capabilities. In this segment, I will illustrate how WAVE serves as a microgrid controller, effectively managing a comprehensive hybrid energy system. Earlier, Kate have given introduction to individual assets in the G&W electrical facilities. There are some constraints of grid codes and facility operation requirements. I will use our emulator to show you how WAVE handles these challenges seamlessly, getting the G&W system through normal operation, grid outage, idle operation, and back to being grid connected. That starts with normal operation. This system has dual utility feeds, which have a predefined interlock scheme. WAVE will help the system to achieve decarbonization through renewable adoption. That's meet with WAVE client. Operator will daily rely on this client to do system monitoring and control. To refresh our memory of this G&W topology, it features two utility feeds. During normal operation, the interlock scheme ensures only one feed supplies power at a time. On the bottom left, this is the rooftop solar farm. In the middle, there are two non-critical loads, which according to Kate, these are assembly facility. And to its right, these two are the flow batteries, which have both grid following and grid forming capabilities. And further right, this is the flywheel and the critical load and our backup generator with ATS. During normal operation, the system connects to one utility feed, optimizing PV output and advance the decarbonization objectives. Now, let's observe how the system fast responds during an unplanned grid outage. The site constraint is that all renewables and other production resources must be halted during grid outage. Therefore, you will notice the PV output drop to 0 and battery breaker open. During this period, the critical load is temporarily supported by flywheel until the backup generator comes online to take over. Here is our emulator. I will simulate an unplanned grid outage by opening this sync breaker. You can see the breaker status change from closed to open. Then switch back to wave client. You will see this utility breaker is open. And you will see the batteries breaker also be open, and PV will be kind of open too. So you will observe the generator will be brought online as a master to help supporting the critical load. So this demonstrates how Wave ensures a seamless outage right through for critical loads. Let's dive into the process of load restoration during island operation. Given the flow battery's grid forming capabilities, the system will utilize one battery unit to initiate the black start. You will observe this battery becoming the system's master, prompting the ATS to revert to normal operations and the backup generator to shut down. During this phase, load will gradually to be restored and PV output will resume. Okay. Let me switch the system to manual control so I can have the control for one of the flow battery. I'm opening the faceplate for this flow battery and issuing a start command. So this will help us to black start the system. Because the battery detects there is a outage, so it changed the battery modes to grid forming as its ISOC master and voltage master. And go back to the system view, you will see the PV is changing from green to red, means it's restored, and the two non-critical load now is covered by this battery. And if you dive into this ATS situation, you will see it switch back to normal, and also the emergency gen is be shut down. And let me change system to auto control so the voltage and frequency of the system will be monitored by Wave. So this strategy extends the available right-through period during grid outages by leveraging renewables and energy storage. In this final part of the demo, we will showcase the resynchronization procedure. Once grid's power is restored, a site operator will issue a resynchronization command through Wave. The sync breaker will automatically close once voltage frequency and phase angle are synced. The battery will transition from grid forming to grid state of charge management, and normal operations will resume. So in here, I'm going to open the island control faceplate. You will see the current breaker status is open, but it's ready for reclose. So let me issue this resynchronization command. Once it's issued, it says sync is in progress. Let me switch back to the Wave emulator client. So you will see the frequency and voltage get synced first, and then we are waiting for the phase angle also be synced. Once it's synced with some time delays here, it will close the breaker. Okay, the breaker is changed from open to close. That switch back to the wave here, so it says breaker status close, and then reclose success. You now will see this sync breaker is closed. And battery is switching from the grid forming mode to the grid following mode as a SOC management will be running through by auto control. So this illustrates a seamless resynchronization process without any facility outage. In summary, our microgrid controller effectively manages the sequence of operations during transitions to and from island operations, utilizing various asset types. It rapidly responds to unplanned grid outages to protect critical loads and effectively manages battery modes, transitioning from economic optimization to grid forming operations as required. Furthermore, it ensures compliance to anti-islanding requirements by curtailing PV output when we need and swiftly restoring it during island operations. During island operations, the controller automatically manages frequency and voltage levels, ensuring the stability. Upon grid restoration, it achieves a seamless resynchronization process, minimizing the disruptions to facility operations. Wave is not just a manager, it's a reliable guardian ensuring continuous power supply for critical loads and optimal performance in any situation. As I mentioned earlier, Wave offers a broad range of capabilities beyond just serving as a microgrid controller. You will have the chance to dive deeper into these features in upcoming demos presented by my colleagues. Now, let me hand it back to Kimberly.
Thank you, Jackie. I'm going to turn it back over to Kate now, and for her to give us some comments on the project and the resilience piece specifically, and talk about what's next for G&W.
So from a resilience standpoint, the flywheel has already stopped 19 different outages, and the rest of the microgrid responded to 8 of those, and the 11 were just from the initial installation of the flywheel. Going forward, what we're planning on doing is system optimization, financial optimization, and making sure things are running to support the system as well as towards our ROI. And then lastly, towards the end of this year, we're going to be working with ComEd on installing a DERMS project. And the reason for that is if we go to our alternate source, right now, we have to curtail all our solar and we have to isolate our battery. Once we get the DERMS project in play, we can have ComEd take over and decide how much solar we can generate and how much the energy storage we can use. And that's because our neighbor got there first. They had 3 megawatts solar and 2 megawatt battery, which put them at the max load for the overcurrent that the system was capable of handling. So.
Amazing. You can tell that G&W is very familiar with complex systems and how to handle them well. We have Dave Braun here from Intelligent Generation. He's going to talk about how to maximize that battery asset that you have within your system to really unlock further values within your microgrid.
So as Kimberly said, I'm Dave Braun. I am responsible for business development for Intelligent Generation, and we are a virtual power plant company. We're a member of PJM and Mid-Continent ISOs from the standpoint of being a market participant as well. So we look like generation to the ISOs. I've myself got 34 years in the industry, started out at ComEd, the utility in the Chicago area, spent a long time in retail energy, selling power and buying power for commercial and industrial customers and gas. Got into renewables several years ago with a utility scale company called GlidePath. We had 450 megawatts of wind, solar, and we're a battery developer, and I ran our operating assets there. But came over to intelligent generation about a year and a half ago, kind of bringing all of that background, all of that experience together, and bringing this product here to the C&I space for both microgrids and with batteries. Pat Avery, who used to be Kate's boss at G&W before he retired at the start of the year, he was responsible for the microgrid business at G&W. He called us the cash register for the business. We manage the value stack for our customers. Probably a lot of you are familiar with that value stack, but I'll cover that here, talk a little bit about that. So these are all the different things that a microgrid, especially with batteries, can provide from a value standpoint. And so we're looking at this on a continuous basis and optimizing how the microgrid is running or the batteries are running, especially to be able to deliver the maximum value to the host customer. And we're doing that in real time and looking at that and then sending the signals to Spirae's site controller to be able to operate that. And so in doing so, we're optimizing the system. That starts with looking at energy from the top. A lot of people think, oh, battery, you charge it up during the day, charge when the prices are cheap, discharge when they're expensive, or charge up with extra solar during the day, dispatch it later. And depending on where you are, yes, that might work. So it's something that we're always looking at, but not necessarily something that pays off in PJM. And one thing to really understand here is these are very locally specific value stacks. You can't apply one set of parameters, one set of assumptions, and say, all across the country we can do this, it's all going to look the same. A lot of the systems we've seen are designed for California and that duck curve and all the tariffs they have out there to take care of that duck curve issue, where they've got too much solar during the day. They need more power at ramp time, so they've redesigned their tariff structures to be able to take care of that. So you really got to look at those structures case by case. In PJM, there's really not a lot of or not enough value change or price change between day and night, even seasonally, to really create a lot of savings here and a lot of value in the energy component. I do have some customers that like to look at saying, hey, can we, our interconnection is limited, can we store some energy, deliver it later? And say, yeah, it's not going to be the most optimal use of that battery, but yeah, we can look at doing that. Another big thing is demand, right? So those who are familiar with utility billing, if you're a commercial customer, you get billed for two things in general. One is the energy that you're using, and the second is how fast you're using it. That how fast you're using it is the demand charge, is the KW. So you got kilowatt hours that are like how far you're going, the odometer in your car, the capacity or demand, those KWs, is how fast you're using it at peak. And again, it depends on the tariff whether you can do anything with this or not. In California, they've got real short windows where they've got really, really high prices for demand, and so you've got an opportunity to charge up when demand is cheaper, discharge the battery when you're in high demand periods that may only last 2 or 4 hours, and really decrease your cost. In most of the markets here in the East, you've got demand that's measured in an equal either 24 hours a day or at least on peak. There may be some super peak hours that you can take advantage of, but oftentimes in ComEd's case, where Kate's factory is, they're measuring demand from 9 to 6. So there's not a lot we can do to reduce that, because if we take out some in the middle, it's just going to peak at either end. So there's really not a lot of value there. Where there is a lot of value in PJM is in capacity and transmission. And as Kate referred to earlier with these 5 CPs, 5 coincident peaks, in PJM's territory, the amount of capacity, and this is generation capacity we're talking about, you have to buy, is based on what the facility was using during the 5 highest grid peak hours of the year. And the other piece is transmission. Again, it's how much you're using during those 5 transmission peak hours for your utility zone for the year. So you could discharge the battery maybe 5 times and knock a third of your bill off. It's that drastic, how much that is. 25% to a third, depending on what the rates are in any particular year. So one thing that we're doing in PJM, this works partially in MISO as well, we're actually forecasting when those grid events are going to occur. You don't know when they're going to occur because it's a look back. So they're going to look back at the end of the year and say, yeah, it was June 5th at 10 o'clock or 2 o'clock, it was July 11th at 4 o'clock, it was August 17th at 6 o'clock, whatever. Average those together, that's your cost. So by forecasting that, we're charging up the batteries at our customer locations, charging them up overnight, discharging them during those hours when we think that's going to occur, and reducing their what are called peak load contribution values by the size of the battery, basically. In some cases, that can take the customer's capacity and transmission to zero. And again, that's about a third of the bill. So we do that maybe 10, 20 times a year. The rest of the time, the battery's sitting there idle or just in standby mode waiting for an outage. And so there are other things we can provide. These are, in many cases, things like grid balancing services. Ancillary services, they're also called. Things like frequency regulation, synchronous reserves. These are some of the areas where the grid will pay batteries or paying customers. They'll pay customers to get off at certain times to be able to help balance the system. In the case of frequency regulation, that's a 2-second signal. So most customers can't adjust load in 2 seconds unless you have a battery. And so in that mode, we're bidding our collection of batteries in, like a virtual power plant. We're bidding that into the grid, getting selected most of the time to run in that frequency regulation mode. And then in that case, the market is sending us a signal every 2 seconds. And we're reprocessing that, just sending it out to our battery fleet and responding to that market signal. We'll see that as a demo in just a minute. Other services like this are synchronous reserves, and there's some others. It all depends on what market you're in, but generally, frequency is something that has to be maintained. Voltage is something that has to be maintained no matter where you are. Thomas Edison dealt with that in, the 1880s when he first strung wires in New York to light up light bulbs. He had to balance the frequency on those. So it's a very important grid service and gets paid quite well. I'll talk about that in a minute. The last thing is resiliency. Kate didn't tell this story, but the reason for their microgrid, they were having many power outages, which is ironic since they provide the smart grid systems that keep the grid on, but still they're getting interrupted for short times. Even few cycles could trip off their injection molding machines. Actually, during a storm, I think it's probably 3 years ago now, there's a derecho storm that came through, knocked out both of their ComEd feeds. The owner was on the golf course, he got a call, hey, the factory's down again, called Pat Avery and said, fix it, I've had enough of this. So, thus developed the microgrid. They think they saved about $2 million in the past 18 months from avoided losses that were responded to by this system. So that resiliency piece is another big part of this. One thing that we do for the developers and EPCs that we work with and our customers is actually we've got a model that models all this for that customer's location based on the customer's interval load profiles, the rate tariffs that they're on, where they're located, and then we can come up with what the pro forma looks like. What's the payback period for this investment? And what is the operating savings, IRRs, all of those things, also including the incentives that we get to, the ITC, any kind of state rebates, accelerated depreciation. In the case of some of these PJM markets, ComEd in particular, where Illinois is offering some very robust rebates, we can get paybacks in under 3 years for solar plus storage. So these are some very great returns right now in many parts of the U.S. So again, what do? We are a virtual power plant company. We talk about things on these lines. So earn, save, protect is our model. So help customers save money on their electric bill, earn money by using their system to dispatch it into the grid to get paid, and then have that system there to protect their operations and keep the lights on. We're the first to implement behind-the-meter batteries in PJM and in MISO. We've been delivering on total battery storage value proposition since 2014, operating behind-the-meter assets since then. We are cloud-based, so we're not something that's on site. We are interfacing with the BMS or the site controller, but we're running in the cloud. And we're interfacing to our battery fleet through encrypted internet. We've got telemetry then we have from our data center back to PJM and MISO, that's dedicated lines. So we got that fast response in security, cybersecurity. But on a real-time basis, we're monitoring what's going on in our fleet of batteries, what their state of charges, state of health, what the solar generation is, what the load generation is. External inputs are things like the market pricing from PJM or whatever the market we're in, the zonal load forecast, weather forecast, and we're crunching all that together and figuring out what is the best use of that battery in that time period, in that second. And sometimes that means looking forward to the next day to say, is that going to be one of those 5 CP days when we need to take the battery out of the frequency market and put it into charge mode to be ready to respond at that time. So we're operating in the cloud, communicating. We've got a site interface that we're connecting through the gateway into the site controller, and that can be customized and modified to whatever the needs are. So we've worked with Spirae for several years to adapt that for G&W and getting their system up and running. We've got a number of systems in place right now. We've got about a dozen batteries or microgrids that we're managing right now, and we've got another probably 400 megawatts of pipeline here that are in various stages of development. But going back, the oldest battery we have operating right now is at Apt Electronics. The question was about, I think the comment was about Alaska. That was the first Tesla battery, lithium-ion battery put in the north. Tesla said, oh yeah, our systems work below zero. Yeah, they do until they don't. They work as long as they're on. And then once it tripped off, it didn't want to come back on, just like some of the Tesla car issues you heard about in this winter in Chicago. So we had there was a special procedure to get it warmed back up, get it back into operation and into control. They ultimately put a heating system from a Tesla Model S into this to keep it warm, and that's their standard package now on all the stuff that they're doing up in the north. But that's a microgrid. They had existing cogen that they shut down when they put 2 megawatts of solar on the roof. They did a 500 kW battery. This is the largest electronics and appliance retailer in the country under one roof. They only have one store, and that one store does the equivalent of 30 Best Buys a year. And all their servers are on site, all their inventory is on site. So they don't take an outage, because every day they're making $3 million in revenue. They don't want to take that out. So we put in the microgrid. It's worked so well, they're putting in another 0.5 megawatt of battery plus another 250 kW of solar on the recycling center. They take all the appliances back, they crush them, they ship them out for recycling, and everything else they take back. So again, that's operating as a microgrid. Maggot Glove, Kate referred to the other customer that beat them to the interconnection agreement, and that customer is Maggot Glove. They're about a block away. They've got 3.8 megawatts of solar on the roof, 2 batteries, again, backing up that facility, as well as providing the renewable energy there. Libman Brush and Broom Company is in Arcola, Illinois. That is the first and only behind-the-meter battery in MISO. So they've got about 2 megawatts of solar on the roof, and then a 2 megawatt battery that's providing backup for that facility. Same issues that G&W has in terms of outages, taking out their injection molding machines, as well as providing frequency regulation, and then the big G&W battery there. For those that haven't seen, I don't know if we showed a picture before of the cell cubes, but that's what they look like there in that bottom corner. It's 20 shipping containers stacked 2 high. It's quite an impressive system. But from a footprint perspective, the Libman Tesla battery to its left in 2 containers does the same amount of energy. But there's a lot of life cycle benefits that come with the flow batteries that attracted G&W to that system. So that is what we do. Can I break for some questions for a minute before we jump into any questions from what we do? Yes, sir. Our economics so far, none of it has been based on augmentation. And like I said, we're expecting 15 years out of the lithium batteries. In the case of the flow battery at G&W, that's expected to go 25 to 30 because of the chemistry. So we haven't, our customers aren't looking at augmentation really because the business case doesn't require it. We're looking to hit, on the 5CP case, we're looking to hit just 1 hour of peak basically in the day. So having the extra cushion around that is good. But even if that 4-hour battery decays to equivalently 75%, beyond that it's going to crash very rapidly, right? So once it gets down to that stage, we still have 3 hours of duration there. So we should be able to cover a 1-hour case. And then the frequency regulation is following, that's in real time. We're floating the battery at 50% SOC and letting the market drive it up and down. So that really has not been an issue from a duration perspective. Yes? With the incentive, all the incentives in place, 3 to 4 years, typically. That's in Illinois with our extra rebates. Other parts of PJM, we're seeing 4 to 5 year paybacks, just with the ITC without additional. Including ITC, including accelerated depreciation. And then things go even better when we're in some of the high-priced transmission markets like AEP or PSEG, some of those markets that are over $100 per megawatt, $100,000 a megawatt year in transmission pricing. So we can generate a lot of value there. Good. Should we transition then to the demo? So I'll do a quick intro and then turn it over to Nevin. So again, this is going to demonstrate when the G&W battery is in frequency regulation mode. So this is probably going to be 85-90% of the time when we as intelligent generation are bidding our assets into the PJM frequency regulation market. This is a market-based price service. It's about 90% correlated to the price of electricity, meaning the real-time price of electricity, which is about 90% correlated to natural gas on a spot basis. So over the past roughly 13 years, 12 years since it's been a market, the average price over that entire time has been $32.50 per megawatt of participating battery per hour. This market, you can participate as fossil, you can participate as battery. The battery signals are a little bit more intense, more variant, because batteries can respond faster than a fossil station can. The max this product has paid is $4,700 in 1 hour, and that was Christmas Eve 2022 when a winter storm came through the Great Lakes region and really caused a lot of imbalance in the system, and that's when this tends to pay a lot. So when we're in this mode, we're getting a signal every 2 seconds. You can see an example of what that signal looks like, and then I think I'll turn it over now to Nevin, and he can show you how the battery performs through the Spirae system.
Thanks, Dave. Nevin, take it away.
Hi everyone, I'm Nevin Thomas, software developer at Spirae. In this demo, I'll be showing you how you can schedule the battery for market participation program. So to understand this program, I'll be going through overall data flow from frequency regulation market to the batteries and back to the market. Next, I'll demo the scheduling of the batteries for this program through Wave software. Finally, show how the battery responds to frequency regulation signals being dispatched by the intelligent generation for grid optimization. Now moving to the next slide. In this diagram, we have the data flow from FR market to batteries and back to the FR market. So let's break it down starting from the left side. Here we have 4 levels: the G&W, the asset owner, Spirae, the microgrid control, intelligent generation, which helps in grid optimization, and finally PJM, the regional transmission organization. And on to the right, we have the Wave software, the microgrid control software at the site, and the microgrid where the batteries reside. Along with that, we have the sequence of numbers which represents the overall data flow. Towards the top right, it shows the nameplate capacity of each battery. We see the portion of batteries, 2 batteries that will be participating in this program, with the 75% limits set as a criteria for the participation. Starting from the lower level, we have PJM, which sets up and manages the market. IG participates in this market by submitting a bid. Once they win the bid, they will communicate with G&W to prepare the grid by scheduling the batteries through Wave software so that frequency regulation signals can interact. Once the scheduling of microgrid has been set up, FR signals from PJM will be sent to the intelligent generation. From there, the fast signals which are generated every second, will be relayed into the batteries through Wave's API services. Then the batteries will react to the fast signals and the response is then submitted back to PJM, and they will provide revenue based on the response. So that's basically on the overall data flow. And now moving on to the next slide. Here we have a simplified version of data flow which we had just seen from the previous slide. Here we have the PJM sending the frequency regulation signals, then the intelligent generation which will try to retransmit these signals to Wave software through Wave's market participation service, and from there finally into the asset, which are the batteries that will respond accordingly to the signals. From there, the response signals will be sent back into the IG through Wave software and finally into the PJM market. So that's on the data flow for the frequency response. Moving on, here we have the trend view of the frequency dispatch signal generated by a signal generator tool, which is simulating the signals produced by intelligent generation. So now I'll move on to show how to set up the batteries for scheduling through Wave's user interface, see how the batteries react to FR signals, which will be simulated through a signal generation tool. So moving on to the Wave's client user interface. We're now in the Wave client user interface, and towards the right we can see the system one-line view of the microgrid. So if we zoom in, we can see the two batteries that will be going to be participating in this program. So right now they are both in idle state. To make sure these two batteries participate, we have to enable the market service mode. So let's enable that. Now we'll start the service. So once the service has been started, we need to schedule the batteries so that they can interact with the FR signals. So let's go into schedules and select the batteries. Select the desired batteries to be scheduled. Select the desired time range. For 829 to 33, select the desired service and save the schedule for first battery. Now we will do the same for second one as well. Select the desired asset. Now both of the schedules has been created, and to make sure both of the schedules get executed, we have to set the wait into a specific control or operating mode called schedule control. So let's switch to that operating mode. And now let's wait for the schedules to get executed. So once the time hits, the schedules will start to get executed, and we can see how it will show up in the UI. So right now we can see that this two schedules has been starting to get executed. Now let's go into the signal generator tool to send the FR signal. So this will simulate the IG's process. So let's go into the tool and start the FR signals. So this will be sending the signals into the batteries, and we can see how the batteries, two of them will be responding to these signals. So now let's go into the faceplate. Here we can see that one where the in red color, which is the active power set point, which is sent by the signal, and the total active power, which is the green color, which is how the battery is responding to the signals. And this is for the first battery. Now let's see the similar waves in the second battery as well. So here we can see the similar trend view in the second battery as well. The red showing the set points sent from the signal generator 2, and the green showing the active power, which is representing how the batteries react to this signal. So that's basically on the demo side of it. So moving back to the presentation. So if you have run that over the period of 10 minutes or more, we could have seen the similar trend view in the Wave UI. So in short, we saw the collaborative roles of PJM, IG, G&W, and Spirae in this program. We observed how the batteries were scheduled using Wave Scheduler, and we also saw how the FR signal is transmitted from PJM to Wave by IG and finally on to the BESS through the help of Wave services. So finally, to wrap it up, we saw how the Wave plays a critical role in managing BESS for resilience events. So that's all on my demo, and thank you for listening.
Thanks, Nevin. So far, we've seen the resiliency value that's available through microgrids, those additional values that you can unlock with assets such as batteries. And next, we're going to have Raman from Rolls Royce talk about the value of decarbonization and what they're doing in that space.
Hi, good afternoon. This is Raman from Rolls Royce. I'm responsible for controls automation and electrical engineering for 60 Hz market. So today I'm going to tell what do we do at Rolls Royce, what do we see the power generation at Rolls Royce. So we have a wide variety of products that are available, and how do we put those together. And yeah, I'm going to go on, and at the end I'm also going to touch base how the sustainable fuels in our internal combustion engines are capable of. So those are the points I'm going to touch base today. So if you see us, we are part of Rolls Royce PLC from UK. So we come under the hood and we work in power systems. So if you're wondering, there is no Rolls Royce motor cars here. Yes, you are correct. So Rolls Royce sold motor cars to automotive OEM about a decade ago. If you still wonder whether we own a Rolls Royce car or I won't, so no, we don't own. So yeah. If you see here, Rolls Royce has good stake in power generation. If you see here, 34% of our market is in power generation. So apart from marine and industrial. So yeah, we do a lot of projects worldwide in power generation. So we have global presence both in 60 Hz and 50 Hz market. We do wide variety of projects over the globe. And yeah, we do say our vision is power that is good for planet. So we work in that line. So we try to fulfill our customer needs. Also, we consider the planet as part of our ecosystem. So yeah. If you see the market trends, so everything is digitalization, decarbonization, and electrification. So why do I have this slide? You're going to understand in next couple of slides. So yeah, a lot of customers, they rely on the grid, so they need backup power, especially if you see here, the industry, data centers and hospitals, they need backup power. This trend is going to be high, so according to our analytics, so this is keep increasing in coming years, it is not going to decrease. To have a reliable backup power, so most of our customers, they buy products from us. And yeah, there are new business models that's also coming into existence. So just like our panelists, they told, they have virtual systems where they can share the power. So yeah, we used to be a traditional internal combustion engine manufacturer. So we are shaping our company future to be a solution provider. So we also support right now life cycle services like maintenance of our customer grids and also maintenance of the DERs of our customers. So if you see, back in the days, we used to sell only the gas and diesel, and today we sell the complex systems together with gas and diesel. And the future, we are looking for seamless stacks where we can give continuous power to the customers. So this is our product portfolio. So we have original equipment, we do have the systems, and if you see here, there are some interesting things. So we do power packs for rails, we do dynamic uninterrupted power supply troops, and we also provide battery containers and fuel cells. So we are also working on hydrogen internal combustion engine right now. So these are our products in our portfolio. So if you keep all together in a system, so we can do our own microgrid. So these are our DERs which we produce. So we also combined, and we also have a validation center in Germany and also one in US. So where you see it works with our automation system. And we do partner with Spirae for energy simulator. If you see there, you can simulate using the Spirae's wave software where you can simulate your own model. The next one is the validation center. What do we have in our validation center? So we do have gas and diesel gensets and hydrogen blending genset as well. We do have a battery container, fuel cell. Of course, those are all connected to grid. And the energy, whatever we get from these systems, will serve our own facility as part of energy infrastructure. So I just kept this project as an example because most of our customers, they still want to include some of the gensets, including battery power packs. If you see here, so they got 2 standby gensets and also 3 CHP gensets. So this is the application where we did in UK for a logistics park. So initially they want to have just battery containers, but if they want to have a reliable power without any failure, we have suggested to take some of the gas gensets as well in part of the project. So this is a special one. So we do work with federal government in Germany. We partner with them to have a cleaner harbor with 3 fuel cells. So right now we deployed 3 fuel cells there, and we are also doing research for a full hydrogen internal combustion engine. So actually the fuel cell is already commissioned, it's working there, and we are testing our hydrogen engine there. So I'm going to touch base some of the alternative sustainable fuels for diesel. So if you see here the well-to-wheel ratio of a HVO diesel, if you use that, you can reduce the emissions. So we also encourage our customers to reduce the time intervals. They use their diesel generators from every month to every 3 months, so they can reduce the emissions. So we provide exhaust gas after treatment systems as well to reduce the emissions. One thing, so we encourage nowadays HVO diesel, so where you can drop in with our existing diesel generator systems. So you need not to do anything else, you can just drop in and our generator performs with the same capacity and the performance. The advantage for this one is you have less emissions. You also get some of the incentives with different governments, both federal and state governments. So if you see the difference of the emissions, so that's a fossil diesel on the left and the HVO on the right. So you can emit a lot of, you can limit a lot of emissions using this fuel. So that's it from my side. So I'm here as a genset manufacturer, nothing from the grid side or utility side. So if you have any questions in that area, you can ask me. Thank you.
It's amazing. It's cool to see that there's many different paths towards the goal of net zero, including combining conventional generation and renewables. We're going to see that in action now from Steve Ulrich. He's one of our senior software architects at Spirae.
Hello, my name is Steve Ulrich, a senior software architect at Spirae. And during this demo, I'm going to show how you can extend your conventional generation sites with renewables and battery energy storage to extend the life of your site whenever you have a grid outage event and you need to have emergency power. This will also contribute to your carbon and net zero targets, as well as extending out the life of your island by using the renewables. Also, you'll get an economic benefit because you're going to be reducing your use of fossil fuels and the cost of that. So what we have here is on the top track, I've got a representation of a conventional generation site. And whenever that gets deployed during the operations of that site with the conventional generation, when you have an outage, then that will be serving your critical loads as the backup power. And in the bottom track, we can take that same site, add in some renewables and battery storage systems, and with that now new hybrid power plant deployed to the site, now you can take advantage of all of your assets. During this demo, I've got three main sections. The first section is I'm going to show how you can use a configuration tool to configure your site from a conventional generation one to now extending it out with renewable assets and battery storage for our goals. So now I'm going to switch over to our configuration tool, load up our project. This is a representation of a conventional generation only site. It's got the grid connection at the top, 3 backup power plants, and 3 critical loads are represented here. So now when we want to extend this out for renewable energy, I can load the project up, click on our main bus bar, and when I click on the main bus bar, now this gives me a number of options that are available for us. So I can select to add in my batteries and my PV to our bus bar, and this now makes these available for use in our site. Whenever I've added these in, I can also go into the system and I can customize those to change any of the make and models or the ratings of the assets. I can say how much connected battery it has or the type of mode of operations we want to allow the batteries to perform. The same thing with the PV assets. I can say how much of a PV array we actually have connected here. Once we've got this in place, then we can adjust any of our other system settings to say how we want the behavior of the island control operations to run with those new assets. And then once we've got all of those configured, we can save this and deploy it to our site. In this case, I've got everything deployed against an emulated environment. So now I'm going to switch over to the second part of the demonstration, which is actually running through a grid outage with conventional generation only and see how our site can actually be supported for the critical loads with just the conventional generation. What we have in our one line here is I have the conventional generation on the left-hand side. On the right-hand side, we've got in green the renewable assets. Those are currently made not available in the emulator. So we're just going to be supporting the island whenever we actually have an outage with just the conventional generation. So I'm running an operation now to do a balanced and island operation. This will do a planned island outage, which will synchronize the power flow across the PCC. And then as soon as the power flow is at a certain limited level, then it will open the PCC breaker to island the system. So inside of the trend here, you can see that our green line represents our PCC, so it's right around 0. And you can see now our grid breaker actually opened. So now we're supporting all of our critical loads in our site with just the conventional generation. Gen 1 is currently selected as the master asset, so it's the grid forming asset on the site. Now the next section, I'm going to switch over to our renewable assets being used. So I'm going to go into our emulator and enable those in the system. And when we'll see that those are used, then it will start to show the benefits of transitioning away from the conventional generation. So as I now go into my emulator and start to bring up my assets, I've just brought on the first battery. It's been brought online and already selected as the master asset. All of our generators are now just being used as just backup storage, and it will slowly be ramping those down to switch over to using the batteries and the PV, which are now also being brought online here. If we do end up having any excess power from the PV production, and we have a low state of charge on our batteries, then we can actually take that excess power, put it into our batteries as needed. But right now, what's happening is our controls are starting that process of transitioning away from the conventional generators. It's going to be slowly ramping those down in a stable situation so that we maintain our current island while it is starting to use those batteries and the PV to support our critical loads. So what we just demonstrated was that behavior. This new visualization tool that we just are showing here has the ability of actually showing the representation of, in this case, just the PV profile throughout the day and how it can actually show as we're actually using our PV for offsetting the conventional generation assets, how we can actually start achieving our net zero targets and reducing our carbon footprint. And that's what that the orange line on the top is all about, the showing the PV profile for the day. And then this is a small sample during the middle of the day on the bottom graph on how it's actually reducing that carbon output. So hopefully with this demonstration, I was able to show you how we were able to take a site that was only using conventional generation. With a configuration tool, we can quickly change that over to now adding in renewables and battery storage into the mix. And then as soon as we deploy it and we want to run with those, we can actually start to effectively use those renewable assets to reduce and offset how we're using conventional generation for riding through grid outages, extending the life of your microgrid, reducing your economic cost for running your microgrid, as well as your net zero and carbon reduction targets. Thank you very much.
To speak a little bit more about what that looks like of not just looking at one individual microgrid or one individual system and the value available there, but actually doing things at scale in a way that will support the energy transition. And we also have Sam Harrell here from Intel. He is hailing from Houston, Texas, although his claim to fame is that his 312 number from Chicago from spending years there. So a big, strong Chicago presence here today. He's here to talk a little bit more, like I said, about the Center of Excellence at Intel and the space they play in that infrastructure for scale. So Sam, I'll turn it over to you.
Thank you. Thanks, everybody, and it's a pleasure to be here. We're excited to be here. It's always good to be in the presence of good partners in this industry. As was mentioned, Kimberly mentioned, I am from Chicago, and I have the good fortune of working with partners across the globe on a variety of issues as it relates to energy transition. I do live in Houston. We are the energy capital of the world, so I say that proudly as we try to extend our influence in what's happening with all of the majors, and certainly how that will intersect with what's happening on the grid. To the last question, I'll give you my take on it, is that hydrogen will be hitting the grid in an ever more increasing capacity, and we should see resources starting hitting the network, and how we manage that, not only if it's hydrogen or other renewables, including geothermal, is going to really test our fortitude on these networks and how these solutions mature. And that's really what I'm here to kind of talk about, is really this disruption and how we play a role in it as Intel. So I, as a representative of Intel, I play two roles within the organization. So you can think of me as the energy guy. I am more like the folks that are sitting in utilities. My background is in utilities. I work for Exelon, both ComEd as well as Potomac Electric, here in DC for years, and in other places too. I've also worked in oil and gas. I was the energy guy for Marathon Energy and Energy Infrastructure, so I know what it is to put load behind the utility. I had 1,500 megawatts of load behind my refinery. So in saying all of that, I understand the customers, and I try to bring that view into what we do from a development and a product standpoint and a relationship and partnering standpoint within Intel. My focus is always on the end user. It is how can we solve the problems that we've been talking about today. That second part of how I introduce myself is one part in the market, and it's the other part in terms of what I do to help Intel. So the best way that I describe it is I try to help the company eat our own dog food. And so because we are a very, very intensive energy user in our fabs, I try to lend that expertise into what we do. And so I understand energy intensive users, not only because I've been one, but because I work for one, and I try to guide that within the organization. What I'm going to do in the interest of time, I'm not going to go through the realities of the market. You have heard a lot about that in not only the demos, but in the earlier presentations. Let me just say this, even though I whisked through it. Our point of view is the exact same as our esteemed panel here in terms of how we see that market moving, and I'd argue that it probably isn't any different from what you guys see in the market as well. How we confront this divide in the market in terms of this intersection between IT and OT is very critical. Because the market, that physical and digital is becoming seamless, and we're working through a lot of the challenges around cloud and AI and integration and seamless execution, etc. This is what we do in our day-to-day at Intel. I want to touch on this a little bit because I think it's important, specifically from our point of view in terms of what we believe modern grid systems are and where sort of the heart and soul of the system is. And that is at the substation. So this rendering here, pictogram, is all about the substation being that central intersection point that we need to take aim at in order to be able to revolutionize how we get all of these grid resources not only on the grid but into action economically. So that's what you've been hearing here today, and we believe we have again a point of view on what a software-defined infrastructure means in terms of doing that. And so we spend a lot of time not only on product development but on alliances and partnerships that really speak to this need to really manage these resources on a 22nd century grid. This is where things are going, and this is where we're making investments across the globe. Doesn't matter where it is on the planet. There are certain guiding principles. You've heard a lot of them today. I'm not going to go into this. The beauty of this is partners like Spirae and many others are really leveraging these principles. I can't be more excited as you look at these 4 demos and these building blocks and elements of technology are super critical for how we will be able to execute along these planes, whether that is in the design of infrastructure. When I say the design of infrastructure, really, I'm talking about the design of compute infrastructure to support these needs, whether that's AI, whether that's edge technology or edge intelligence and the like. I think all of these things are critical in terms of building this out. And certainly all of the business value that's associated with these are ever present and or growing, and we're going to be focused on it. Here's the slide that Sam uses when he's talking to customers. I don't do a lot of talking about the next generation of chip. I won't talk to you about networking and all of that. These are, for me, the plumbing. And I, in a football term, it's blocking and tackling. That's how we play the game. Really, what I talk to customers about is about this, and I could spend a day just talking about, all right, what does the market, what does the end-use economic buyer want to hear from the folks in this room? And it really is along these lines, and depending on the sophistication and maturity of the customer is where you're going to have these conversations. Now, we've been talking about a lot of this stuff already here in terms of what we're trying to deliver in terms of in-state capabilities and what is the as-is and to-be state. And it's going to differ depending on where you are in the world, and it certainly is going to differ in terms of what investments customers have made to be able to get to where they are now. And so, we see this as a fluid state, but it's all about delivering this incremental value over and above where customers see themselves today. As I mentioned, I talk about the power of the alliances. I'm going to skip through a little bit, and this is sort of under the hood in Intel is how do we work with the likes of Spirae and many others at this conference. Kohler Energy is here. They're a customer. Helia Technologies and Honeywell and Schneider, and I could go on and on. I was at a conference a few days ago in Anaheim, and there were 1,300 folks, and I'd argue that more than half of the partners there were Intel customers. I have the ability to be able to play along all of these planes when you're building solutions because of who we are as a technology company, but it's very critical for us to understand how these things sort of collapse upon each other. How can the design of technology merge with the identification of the right use cases that merge with the ability to deliver that with multiple solutions that integrate seamlessly, that when laid in front of a customer drives value that maybe you take a position on. You can do guaranteed resiliency, for instance, or you can do ancillary services that was talked about earlier and provide that as a service, and I could go on and on. This is the way that we do that here at Intel, and there's a sort of a methodology that we work through. And then I'm going to try to talk to 3 slides real quickly. I'm not going to go through all of this because you've actually seen a lot of this showcased in all of the demos, and the 4th demo that will be coming after me will showcase even more of this. But there are sort of three-layer cake in terms of what's important in terms of technology and why is that important for scale. And we start with that sort of edge native platform that is baked in really at the hardware layer, and what benefits are we trying to deliver to that. Chief among those that we'll talk about again is sort of this fleet management, what I call day 1+. What happens after you deliver and deploy something in the field, and then how can you manage that device and or 1,000 and or 10,000 devices, and what's necessary to do that, and do that very seamlessly at the edge across a diverse and heterogeneous environment. The second part of that is where we work and talk about how do we start to develop AI / AI software / decision science in a way that's deployable and manageable as a service. And there are a number of different components that are critical to do that in terms of how do you develop that in a hybrid environment, how do you look at that software supply chain, how do you manage that, and how do you deploy that in a way that is edge native and can work in any environment. And the orchestration of that, as you saw through the earlier demos, this is not an easy task, and so working with partners that can figure that out is important. And then the last leg of the stool is that simplified solution management. How do you take all of these parts together and be able to work that through in a customer design or a solution design that is preserved, manageable and configurable, and what are the tools that are necessary to do that, whether that's working in terms of deployment or whether that's looking at an infrastructure solution that at the software level can reside in the cloud, can reside in a data center, public, private, whatever, and at the edge. Those are the building blocks that we look at. We believe that this is necessary to drive solutions at scale. There are a number of components. Obviously, technology and networking is a big part of that. The autonomous nature of solutions in terms of these deployable services that really provide decisions into applications, fleet applications and or asset management, field service applications, and or customer experience applications as customers want more and more insight into these assets that are on the ground. So that's how we manage it. And I will really start to move into this demo now to be able to provide that second action.
All right, Patty, take it away.
Hello. Keep it brief. We're pretty much right on the end of our time frame here. I just want to touch upon what Sam was speaking of in terms of orchestration and deployment. A lot of these applications that we're talking about are not necessarily in the most hospitable places in terms of application development and deployment. And so how can we leverage technology and software to help us bridge that gap and make that edge node so much closer to where we are today. So the first step of that is by creating a network operations center. So for the sake of operations today, my laptop is my network operations center. And this little baby right here will be representative of what you might have in the field in terms of a microgrid controller hardware, piece of hardware. So what I'm going to do right now is I am going to connect to my control center. So I am going to deploy a wave installation right now named Matt to my site, which is this baby right here. And so we're going to go MGK demo, and I'm going to go site 1. And so with that singular command, I have now sent the execution of deploying a wave installation to this machine right here. And from anywhere else in your connected network, you can then access that machine and configure, run, operate, troubleshoot, gather data. And Steve, would you mind bringing up a web window and going to mat-wmw.local for me? So there we go. So now Steve can then log into Wave directly, and from that control center or from your home or from any other portion of your network, you will be able to log into the microgrid controller and access and configure that particular installation. So when we speak about the ease of deployment, this is what we're talking about. And what's amazing about this is not only can you do that for a singular node in your fleet, you can then replicate that 100 times, 1,000 times to every single node you have in your network. There's a bunch more slides that I can get into, but in the interest of time, I just wanted to impress upon you that a lot of the technology that Intel is bringing to the table is definitely something that Spirae has been looking at to leverage in being able to meet specific use cases in the field, whether that's a hospital a block away or a solar farm that is 1,000 miles away. Leveraging that technology and that infrastructure can really help facilitate and keep your costs down. So therefore, really just bringing this whole microgrid and energy and renewables, into one beautiful little package. So with that, I think I'll hand it over to Sunil and let him close these things out. Thanks, guys.
Well, first, a round of applause for Sam, since we kind of forgot about it. thank you to all the panels for setting the stage in such a fantastic way for me to speak for the next half hour. Don't worry. I decided to change my presentation. I'll just make a couple of points and maybe have a couple of questions that all of us can get into. As Sam was speaking and Patty was giving her demo, I just thought that I have to reinforce one point here. I'm sure most of you have been in the industry for a while. You've seen many, many microgrids, maybe. But the joke in the industry is, if you've seen one microgrid, you've seen one microgrid, right? So the general assumption is that, it's complex, it takes a long time to build, and it's a big undertaking. It's like building a power plant, right? So that's kind of pervasive in the industry when we think about it. So that makes it a sort of a replacement for a power plant, maybe smaller, maybe hybrid, but that's how people think of it. But what Patty just showed is actually more akin to what we saw during the telecom deregulation and, the late 80s, 90s, when suddenly the services that were available to us just, blew through the roof, right? Just completely transformed the industry. Right? Who wanted anything other than a little handheld phone? Right? We didn't even know any different, right? And then suddenly, there you are, smartphone, you can't live without it. That transformation had a lot of underlying infrastructure changes. One of the key things was provisioning services anywhere in the world instantly from, some remote location. So, what Patty showed, I just want to build on that and point that out a little bit. The idea that microgrids can be provisioned like that is, I think its time has come, and I think we're going to see a lot of things change because of that. So what's the implication? What does that really mean? For me, the question that it raises is microgrid a thing, or is a microgrid really a catalyst? I think it's a catalyst. If it's a catalyst, what is it a catalyst for? It's actually a catalyst for delivering energy services anywhere at the click of a button, right? So you can actually transform how we think about energy services. We've been talking about energy as a service for years. Has anybody seen one? Right? So you actually put a financial wrap around something, call it energy as a service. That's necessary, absolutely. But now if we can actually activate these types of services for all the 1,300 service providers that Sam was talking to last week, and if they can go to their customers, hundreds, thousands of customers, and provision these services, activate them, it'll transform the world as we know it from an energy perspective. So I think microgrids are a catalyst, they're an enabler, they're the accelerant to actually transform the industry as we know it. So that's what I believe, and been at it for a while, and I've been waiting for that complete microgrid transition every 5 years, right? And we are still there, but I think we're getting close, and I'm very excited about it. And so with that, I think I'm going to open up for a few questions to the panel, and see what they think about microgrids being ready to change the world. Who wants to go first? Oh, come on, Sam. You can do it.
I'll go, and I'll just say this, and I'm speaking from an innovation perspective, and I just say this: be accepting of the changes that are happening through innovation, and how that can transform your business, and how that can help you move the needle on the services and value offerings that you can create. Similar to what you just said, it is net new territory. This is a new age. It's exciting times to be in this industry. There's a lot of things that are not going to be the same, and there are a lot of things that won't survive, and that's exciting to me anyway.
Kate?
Well, the way I see microgrids, they're going to happen. It's just a matter of how and when. Another aspect that's not really being looked at too deeply that I think needs to look at a little more is end of life of components. We're coming up on a wave of solar panels, some energy storage. There's really no recycling going on. There's some reusing, but at some point they got to go somewhere. And it's something I think that we kind of need to look a little deeper at.
I think what microgrids are really positioned to do is help with resiliency, and that's what a lot of customers are looking at it for, and I think that's going to become a growing issue, and with customers, looking at that, now they can also provide their own generation. If you look at what some of the growth projections are for load in this country over the next 5 to 10 years because of AI, because of the electrification of everything, because of all these transitions to more electricity, the grid's going to be overwhelmed. And both the generation and transmission, I think especially the transmission and even distribution. So to have customers now with these technologies be able to generate on their own, at their own location, get off the grid when necessary, we can make the grid more efficient, and customers can become much more resilient, much more self-reliant, and with the use of some of the value stack capabilities that we have, can really help pay for that themselves and make it profitable, both a profitable and a resilient and cleaner grid for our customers. So I think that's where things should be headed, and I think are headed.
Yeah, we see it fits both customer needs and also in a financial way. So for us, most of the products we sell them as an insurance policy. So they buy our products for standby power. At the same time, we want to fit in their financial needs. So whatever we innovate, we make sure it fits for the customer needs. So we don't want to innovate, and one good thing you said is how to recycle the products after 15 years or 20 years. So you just buy it, use it, and you can't throw anywhere else, right? You have to recycle it. So we see how this whole life cycle works, and yeah, personally, if you ask my perspective, we just want to make sure we don't throw anything into the environment which is not good for it. So, yeah.
Let's take some questions from the audience.